In this lesson, we're going to continue discussing solving systems of equations, and we're going to continue with the same method, the elimination method. Yesterday, with the elimination method, we had a common coefficient that we could eliminate by either adding or subtracting. Today, we're going to focus on the elimination method when there is no common coefficient. If you don't have a common coefficient, to do the elimination method, you need to multiply one or both equations. You multiply one or both equations by a number to create opposite coefficients. Once you have opposite coefficients, then you can follow the steps to completing the elimination method. Let's take a look at some examples. Number 1, you can see that the equations in the system are lined up, my x's, my y's, my equal sign, and my constants. But I don't have matching coefficients. My x coefficients are 1 and 2. My y coefficients are 3 and -7. So I have to create matching coefficients. I can choose to create matching coefficients with my x's. I can choose to make matching coefficients with my y's. Either way, I will get the same answer. You want to choose what's going to be easiest for you to work with. I'm going to choose to make my x terms matching so that I have -2x and a positive 2x. So in order to do that, I need to make my top coefficient, my top x coefficient, -2. So to make that coefficient -2, I'm going to multiply that whole equation by -2. And we multiply the whole equation by this number because if you change one part of an equation, you have to change it consistently throughout the whole equation. So if I multiply my whole equation times -2, I get -2x minus 6y equals 6. I am distributing that -2 to the whole equation. Sorry, I messed up on the end. That should be a -12. 2 times 6 is -12. I'm only going to rewrite one equation because I only need to. My second equation I can just bring over how it is. And now everything is lined up and I have coefficients that are opposites that will eliminate. So if I add the two equations together, -2x plus 2x is 0. It cancels out. -6y minus 7y is -13y equals -12 minus 1 is -13. Divide both sides by -13 and I find that y equals 1, which gives me 1/2 of my answer. So just like with our elimination method before, we take this answer and we substitute it into one of our original equations. And we can choose which equation we want to substitute it in for. I'm going to choose the first original equation, x plus 3y equals 6. So I'm going to take my answer and I'm going to replace y with 1 because that's what I found, that y equals 1. So x plus 3 times 1 equals 6. And then solve. X plus 3 equals 6, so x equals 3, which gives us the other half of my answer. So to write my answer formally, the solution to this system is the ordered pair 3, 1. Let's take a look at a second example. Number 2, I can see that everything is lined up. My x terms are lined up, my y terms, my equal sign, and my constant. And I can see that I don't have matching coefficients. So I'm going to force my equations to have matching coefficients. I can see that my y terms are close. If only that second y term was a negative 3. 3 minus 3 would eliminate. So I'm going to force that bottom equation so that it reads that way. And to do that, I'm going to multiply this whole bottom equation by negative 3. That doesn't change my top equation, so I'll just bring that one over. 9x plus 3y equals 12. But then when I distribute that negative 3 to the whole equation, I get negative 6x minus 3y equals negative 15. Make sure that you're multiplying by everything inside. Then I can simply add. 9x minus 6x is 3x. 3 minus 3 cancels out my y's. Equals 12 minus 15, which is negative 3. Divide both sides by 3, and I find that x equals negative 1, the first half of my answer. Now I can take that and one of my original equations. I'm going to use the equation 2x plus y equals 5. Remember, you can use either equation and still get the same answer. I'm going to take the value of x I found and substitute it. 2 times negative 1 plus y equals 5. Solving that, I get negative 2 plus y equals 5. I'm going to add 2 to both sides, and I get that y equals 7, which is the other half of my answer. So my final answer is the ordered pair negative 1, 7. Go ahead and highlight number 3, 4, and 5. And then on the next page, go ahead and highlight 6, 7, and let's take a look at number 8 together. Number 8, again, I have everything lining up. My x terms line up, my y terms, and my constants. But when I take a look at what I can change to get opposite coefficients, it's not quite as simple. For this one, I'm going to have to multiply both equations in order to get those opposites. And what I'm going to do is I'm going to make my y terms opposites. You can choose to make your x terms opposites if you like. You'll still get the same answer. In order to make my y terms opposite, when I think about the numbers 3 and 4, I could manipulate my equations to make them both 12. I can make the first one 12 by multiplying by 4. 3 times 4 would be 12. Then I can make the second equation a negative 12 by multiplying by a negative 3. So if I multiply them, I get 12 and negative 12, which are already opposites for me that will eliminate. So now I'm going to distribute those numbers to both equations. So my top equation will become 12x plus 12y equals 36. I multiplied 4 times each term in my equation. The bottom equation becomes negative 15x minus 12y equals negative 30. Everything is lined up. I have opposite coefficients that will eliminate, so then I can add. 12 minus 15 is 3x. My y terms eliminate because that equals 0. Equals 36 minus 30 is 6. Then to solve, I just have to divide both sides by 3, and I get that x equals 2, which is the first part of my answer. Now I'm going to pick one of my original equations. I'm going to choose the top one, 3x plus 3y equals 9, and I'm going to substitute that answer I just found into that equation. I found that x is 2, so I'm going to replace x with the number 2. So 3 times 2 plus 3y equals 9. And then I'm going to solve. 3 times 2 is 6. Bring down the plus 3y equals 9. I'm going to subtract 6 from both sides. And I get 3y equals 3. And then divide both sides by 3. And I find that y equals 1. The second half of my answer. My final answer is the ordered pair 2, 1. Remember, when we solve systems of equation, we're finding an ordered pair that makes both equations true. We're finding the point where two lines intersect, where these two lines cross. So if we were to graph these two lines, we would see the point that they cross at is 2, 1. Go ahead and highlight number 9. And I want to take a look at number 10. Number 10 is a little bit different because everything is not lined up. My x terms are lined up, but my equal signs are not. So I need to rewrite one of my equations so that they're lined up. I'm going to rewrite the top equation. So to rewrite the top equation, I simply need to bring the 4y to the left side. Because if you notice in the second equation, on the left side of my equal sign, I have both my x and y term. So in my top equation, I need both my x and y terms to be on the left side. So if I move that over, the 2x stays on the left. If I move the 4y over, it becomes negative because it crosses that equal sign. And then the 18 stays on the right, so it's going to stay a positive 18. I didn't change the second one, so I'm going to bring it down. Negative 5x minus 6y equals 3. So now when I look at this system that's lined up, now I'm going to look for those opposites. And I can see that I don't have opposites and I don't have anything close to being opposites. For this one, I'm also going to have to multiply both equations. I'm going to choose to make my x terms 10 and negative 10. So to make 2x 10, I need to multiply that top one by 5. To make negative 5 10, I need to multiply that by 2. When I multiply my top equation by 5, I get 10x minus 20y equals 18 times 5 is 90. Then when I multiply my bottom equation by the 2, I get negative 10x minus 12y equals 6. So now I have everything lined up and I have opposites, so I can add. My x terms cancel out. Negative 12 or negative 20 plus negative 12 is negative 32y equals 96. Then I need to divide both sides by negative 32, and I find that y equals negative 3. I'm going to take this half of my answer and I'm going to plug it into either one of my original equations. I'm going to plug it into the 2x equals 4y plus 18. And I'm going to be replacing y with negative 3 because I found that that's what y equals. So 2x equals 4 times negative 3 plus 18. And then from here, I'm going to solve. 2x equals negative 12 plus 18. 2x equals 6. So x equals 3. So my final answer is 3, negative 3. So 2 things you want to make sure. You want to make sure that your equations are lined up, your terms are matched up, and that you have opposite terms. If you don't have opposite terms that eliminate, then you'll need to rewrite one or both equations to get opposite terms. Go ahead and highlight number 11 and number 12.